What engineering maximizes rocket payload volume and mass? Imagine trying to fit as much as possible into a small box without breaking it. That's what engineers do when they design rockets to carry the biggest and heaviest payloads. They focus on making the space inside the rocket as large as possible without sacrificing strength or stability. One way they do this is by designing larger payload bays. Increasing the diameter of the upper stage or payload compartment allows more room for satellites, scientific instruments, or cargo. For example, some modern rockets have payload fairings that are over 10 meters wide, giving plenty of space for large payloads. Another key factor is balancing the rocket's center of gravity and center of pressure. If the payload is unevenly distributed, the rocket can become unstable during flight. Engineers carefully arrange components so the weight is centered properly. This keeps the rocket stable and prevents tumbling, which could damage the payload or cause mission failure. They also use advanced design techniques that combine aerodynamics, propulsion, and structural mechanics into one plan. This multidisciplinary approach finds the best combination of shape, weight, and performance to maximize how much payload the rocket can carry. The shape of the nose cone and aerodynamic design also matter. A smooth, well-shaped nose cone reduces drag, allowing the rocket to go faster and carry more payload efficiently. Using lightweight materials like carbon fiber and aluminum alloys helps reduce the weight of the rocket itself. The lighter the rocket, the more weight it can carry. Engineers also make the payload compartments modular and flexible. This means they can adapt to different sizes and shapes of payloads, making the most of available space. All these engineering strategies work together. When the payload bay is larger, the mass is balanced correctly, the shape is aerodynamic, and the rocket is lightweight, it can carry more weight and volume. This is why some rockets can deliver large satellites or multiple payloads at once. It's a careful balancing act that involves optimizing every part of the design. So, in essence, the engineering approach that maximizes payload volume and mass is a combination of enlarging the payload bay, ensuring stability through proper mass distribution, using multidisciplinary optimization techniques, refining aerodynamic shapes, and building with lightweight materials. These efforts allow rockets to carry the biggest and heaviest payloads safely and efficiently, opening new doors for space exploration and satellite deployment.